by 7, nothing different, right? Bring the symbol straight down. Negative 42 divided by 7 is negative 6. And you are writing this example down in that nice big half-page space there. Make a mini number line. Remember, your number line only needs about 5 numbers on it. So I'm even going to draw my own here so you can see what I would really do versus using theirs. I put my number line. I've got my 5 numbers on it. I put my number in the middle for the answer, and then I number around it, being careful in the negatives that 0 would be off to the right and bigger looking negative numbers would be off to the left. And I draw my circle on negative 6, and it's greater than negative 6, so arrow to the right. And I know I'm right. Negative 6 times 7 is 42, and I'm looking for numbers greater than negative 6 that would make this true. So like if I plug in 0, right, I would get 0 is greater than negative 42, and that is true. How about this one? Ooh, a fraction attached to our variable. Anytime we want to get rid of a fraction attached to the variable, we are going to, you should be filling in the blank right now, multiply by the reciprocal. So we're going to multiply both sides by 4/3. Yes, write it down. I can hear you asking. And then we can do a little canceling here. 3 goes into 3 once. 3 goes into 12 4 times. This is a fancy form of 1. And we get r is less than 16. Okay, open dot on 16. Draw yourself a little mini number line. And arrow to the left. Make sure it works. 3/4 of 16 is 12, so that's right. And if I plug in a number like 12 for r, right, 3/4 of 12 would be 9. And 9 is less than 12. So I know my arrow's going in the right direction, and I know my answer is correct. Okay. Now we get to the only tricky part of this lesson, and I know most of you learned this last year, but it is one of those things to repeat because it is so easy to forget this little detail, okay, that makes a big difference. So what happens when we multiply or divide both sides of an inequality by a negative number? So we're going to go ahead and take that inequality that you've got here, 3 is less than 5, and on your paper write that down somewhere down there at the bottom, and multiply both sides by negative 1. So that gives us then negative 3 is less than negative 5. Okay. Not sure if that's true or not. We'll come back to that in a second. Right, and we're going to do this one too. We're going to multiply this one by negative 1. Right, and we get negative 8 is greater than 2. All right, well, definitely I know that that one is not true. And when I go back and look at this one, negative 3 is less than negative 5. No, negative 3 is greater than negative 5. So these are both false now. So when I multiplied both sides by negative 1, they turned into false statements. But those properties of inequality said as long as I multiply both sides by the same thing, then I'm good. So I did something legal. I multiplied both sides by negative 1, but somehow I ended up with false statements. And so the way that we fix this, I know it seems kind of like crude. It seems kind of weird that we could just actually change something in math without a really fabulous reason why. But what mathematicians decided was, well, every time we do that legal math move, we get something false. So we're going to change the symbol, and we're going to make it true. So that's where that idea of flipping the symbol comes from, right? If you're going to multiply or divide both sides, the only way to then make it true is to flip the symbol, and then they become true. I know it seems strange that you could just flip it around, no other reasoning, except to make it true, but that's the way it is. Then you have to remember to actually flip it. So what I want you to write down, and you could write this below the box somewhere, or up above by key concepts is a good place to put it too. When you multiply or divide both sides of an inequality by a negative number, it's what's attached to the variable that matters. Okay? Okay? You must reverse the inequality symbol for it to remain true. Okay? So Sometimes I use the word flip the inequality symbol, right? You can use either word, flip or reverse the inequality symbol. Okay. It only comes into play when the number attached to the variable is negative. Okay, so yes, you would flip it. Okay, this one, no flipping, right? The number attached to the variable isn't negative, right? I'm going to divide both sides by positive 4, so no flipping, right? Both are negative, flip. Okay. So let's try a couple where we have some negatives involved, and these will be the last couple examples that you write down before we're done. Oh, here's another reminder. Don't change the direction of the inequality symbol just because you see a negative sign. Right? Only when the number you divide by is negative. Right? So in this case, no flipping. Don't have to write anything down from here. Just another reminder. All right. Now we'll try it. All right. And we're actually going to make this a greater than or equal to problem. Write it down. We've got negative 12x is greater than or equal to 84. If you haven't learned your 12's facts yet, now's a good time to start practicing. So we're going to divide both sides by negative 12 to get the x all by itself. We are dividing by a negative number, right? It's negative. So that means in our answer we just flip the symbol around the other direction and we do our division as usual. And we do our graphing as usual. So make a quick number line. And once again, my number line is counted by 2's. You can count by 1's if you prefer. And we're going to have a solid dot here, halfway between negative 6 and negative 8. And we're looking at numbers less than negative 7. Check to make sure the arrows go in the right direction. Pick a number that's underneath, that's easy, and make sure it's actually true. So when I plug in negative 10, I get 120. Is 120 greater than or equal to 84? You bet. Notice it's better to choose a number that's not the answer because otherwise it's hard to tell whether it's correct or not. Pick something beside the number itself to see whether your arrows go in the right direction. Last one. Okay. We've got x divided by negative 3. Get rid of the negative 3. We're going to multiply both sides by it. Okay. And that gives us a fancy form of 1 here. Because we multiplied by a negative number, we're going to flip that symbol around the other direction. X is all by itself on the right. Negative 3 times negative 8 is positive 24. Okay. And then read it from right to left. X is less than or equal to 24. Okay. I find it easier to think about it that way than saying 24 is greater than or equal to x, but if whatever way works for you is fine with me. So I'm going to put my dot on 24, right? And then I'm thinking x is less than that, so I'm going to draw my arrow to the left. And then I'm going to check it, right? Negative 8 is less than, right? Well, I know that 24 divided by negative 3 is negative 8. I don't need to check my arithmetic. I want to check to see if the arrows go in the right direction. So I'm going to find a number that's divisible by 3 that's underneath my arrow. I'm going to pick 18. I could have picked 21 or 15. Okay, anything that's easy to divide by negative 3 is good. So I'm going to pick that. And 18 divided by negative 3 is negative 6. And negative 6 is most definitely greater than or equal to negative 8. And that means that it's true, and that was our last example. We'll do a word problem 1 or 2 in class, but that is it. So you should have, look there, it says 7 examples in your notes, along with the reminder about flipping the inequality symbol when you multiply or divide by a negative. That's it.